All right, so how many of you are using PyTorch or PyTorch Lightning in their work? Doing AI for anything? Right? Having the problem of iterating fast with a team to kind of keep up with all the new stuff coming out every day? Is it a common problem for you guys? Yes, okay. So I think both PyTorch Lightning from a modeling side, from a model building side, and our platform from a everything else side are built to maximize your velocity, and I try to demonstrate it for you today. Look at this picture. If you have experience with building models, I think you can relate to it. So there can be an implementation that will get you pre-train or fine-tune for X number of dollars, which is great. The point is, if you put a team working on this, and you look at the bill at the end of the project, that number is just the tip of the iceberg, because you have to make a lot of mistakes and iterations in order to be there. Not even talking about the iterations you need to do to hone in on the real value you want to extract from AI. I have a language model. How does that ameliorate my processes? And you will have to iterate with your own internal customers for it, right? To identify that. But even when you have that value proposition clear, then you will have a lot of things you need to iterate on, like, how do I configure my machine? What GPUs do I use? How do I set up the networking? How do I resume things when things break, and so on? And is the loss going down as fast as it could? Is the learning rate, is the batch size configured right? There's a ton of decisions there that you don't necessarily know in advance about. And so when you read in a blog post, train this for this number of money, that is not the only cost. That is actually your organization cost accounts for a lot more than just that thing. So the ability of your organization of moving fast, iterate fast, try things out with your internal or external customers, and then build new systems or build the same system again until you reach the value, that's the total cost. And enabling teams to interoperate is something that is really hard today. So this is something we've been doing since 2019 when we released PyTorch Lightning. For those of you who don't know, do you know Stable Diffusion? How many of you know Stable Diffusion? A bunch of you. It was trained using PyTorch Lightning. And a lot of other Gen AI models were trained in PyTorch Lightning. When Microsoft presented in their keynote, there was their CEO presenting the models that were in their platform. 50% of them, of those 4, were trained with using PyTorch Lightning. So PyTorch Lightning is a framework that is powering Gen AI today. We have actually crossed 5.5 million downloads per month this month. So it's one of the ways you can streamline development of models. And I would say that the biggest proposition for something like PyTorch Lightning, which complements PyTorch with a trainer, with logging, with all these other capabilities, is avoiding you making mistakes. So when you write training code and you need to iterate over it, you need to run distributed and so on, you really need to understand every single line, because it has big implications on the model not being viable anymore. I've seen a model that was taken from our code base and modified slightly. They added a NumPy shuffle in there that wasn't supposed to be there, and they had to rewind 1 trillion tokens back because multiple nodes were seeing the same tokens. So it's so easy to make mistakes there that if you can delegate the engineering, a lot of engineering, to something that has been done right once, then your organization and your costs will automatically go down because you minimize the surface area for mistakes. And mistakes are very expensive right now. It's not in the the vision days where you had to train a model for a night and that's fine. It's just convenience. No, right now it's actually ability to execute and money to be spent. And the same thing can be applied to the infrastructure. When it comes to operating on infrastructure, if you expose your ML engineers to the intricacies of the cloud, or setting up machines, setting up environments, configuring drivers, and so on. First of all, you're asking them to do things that they're not necessarily expert at. And the second thing is that you may leave a lot of performance on the table because things are not done exactly right. And when you leave performance on the table on a training run that costs you like $100,000, that's a lot of money that you're burning. So what you can do is you can abstract the cloud away in a way that it feels like your laptop, but then you're doing all the right things in the back. And this is what our platform is primarily set up to do. So you can do small things that you would do in Colab, and you do large things as pre-training a large language model, all in the same environment. And I would like to have you, first of all, sign up. So if you can go to Lightning.ai and sign up with your own work email, you will get a free run in Studio. I'll show you what studios are their environments. This is our website. Essentially, what you can do on this platform is you have no environment set up. You can code on an environment and then swap the machine in the back so that your environment will keep working, but you can just swap from CPU to GPU to multi-GPU. You don't have to worry about your environment, your data, your checkpoints being replicated. And yeah, you can want to run on a certain GPU and you'll get it. And your environment will be just right. You don't need to reinstall pip packages or download checkpoints anymore. It's not a GitHub repo, it's a whole environment. The environment that you can share with your coworkers, right? So at that point, I create a recipe and I can share with my company. You can do a lot between training models, serving them, prepping data. So for example, if I have images that I need to resize or embeddings to compute using language models on a lot of data, I can just fan out the computation across machines, and this is just handled for you, and so on. But let me show you and everything you do here, you can fine-tune a 13 billion model with $100 using our pre-built recipes, and I'll show you what that is in practice. And everything you do here can be scripted and executed through an SDK as well. So you can integrate the automation that we give you through the UI within a CI automation. Let me just show you the platform in practice. When you land on the platform, sorry, this is live, so in Wi-Fi we trust, and we'll see what happens. This is what I see. I see an environment that lets me spin up a new studio. New studio is just a machine on the cloud. These are team spaces, which are within my organization. They're like boundaries of collaboration, essentially. Let me go into the right one. I can start my studio. My studio starts. Right now, I'm orchestrating the cloud, right? So nothing happens on anywhere else but our cloud account or your cloud account as well. And I'll show you how we can set this up to orchestrate your own cloud account. And this is a studio that just came out. What is a studio? It's just, it's not the editor itself. It's actually the machine. So I have full control. I can run my Hello World here. This is not very exciting, of course, but it's running. I can also start the web terminal, and I have pseudo access to everything, right? So this is not just some random environment that it sits somewhere. I can actually sudo apt install vim if I'm a Vim fan. So I can do everything, but everything I do here, like if I pip install TensorFlow for some reason, this will carry over to your next environment. Or if you duplicate the studio, because this studio now lives here, although Aqua, I can actually ask a friend in the same team space to just duplicate it, right? In their own team space or in the same team space. So this enables environment to be duplicated across coworkers. And we talked about team spaces, and what is this team space here is something that collects multiple studios, but also data. For example, we have the concept of a team space-wide drive, and the drive is nothing but a virtual file system, shared file system that all the studios in the same team space can access to. So whenever I write to a studio, is accessible from other studios, from other coworkers. And it's automatically mounted in the studios. So there's no APIs, connect to this data source, blah, blah, blah. It's all the file system. And in this sense, this is very much like your laptop, but on the cloud, orchestrating cloud resources and so on. So unfortunately, this is very slow because of the Wi-Fi. But if you do this at home, you will see S3 resources, for example, in this case, ImageNet, that I can connect. I can connect X3 bucket to this drive, just showing up immediately. I can also not just run from scratch, but I can publish in my organization or publicly recipes that can let you, for example, here I will enter a studio that will allow me to fine-tune Llama 213 billion on a studio, on an 8NG machine, using more or less $100 on 50,000 samples, okay? So you can do it yourself. While this is duplicating, it's taking a minute because it comes with all the checkpoints, right? So it's not just duplicating the code, it's duplicating all the dependencies and the data and everything I need to have my experience like bootstrapped immediately. While this is duplicating, I'm gonna show you a few more features here. So let's go back to my home. I have my studio that I started previously, and I want to show you how you can also do things like multi-node training. Let's say we go on the Lightning repo in GitHub and copy this code and just run it here. Here. Oh yeah, they auto shut down, which is nice, right? Because you don't want to be running a GPU for hours, right? So if they don't see activity, you can also like turn off this functionality, but if you don't see activity, you can shut it down. So right now, I'm running this autoencoder model, which is standard PyTorch Lightning autoencoder example, running on MNIST, very simple model, and I'm running it on a CPU. Pretty slow, but everything is working. Now, what's the value of this? Well, the value of this is that since these are replicated environments, if I know it's running here, I know also it will be running on something different, like a multi-node run, because the environment will be exactly replicated in the multi-node run. So there's no discrepancy between you running in your interactive environment and you running at scale, and I'll demonstrate it to you. Let's, for example, switch to a GPU instance really quickly. So right now, I requested a GPU instance, and it will come up in less than a minute. Just because we're waiting for AWS to actually provision the machine. It's not like the actual time once we get the instance is super fast, which means you can also decide to pre-provision instances so your team is much faster. And remember, I can also connect very easily my AWS account to this, so it will orchestrate in my VPC. So it will be up to me, how I configure my account, how I pre-reserved instances with AWS or other cloud providers. Okay, it's ready. I can do the switch. So normally here, you would have to start from scratch and say, okay, I rerun the thing. It's were the data that I downloaded actually persisting? Yes, they're just persisting here. So I can just run. Yeah, see, it didn't re-download the data. The data was already there because I downloaded it in my previous environment that was running on the CPU. Now, what happens if I want to run this multi-node now? I want to run distributed data parallel and so on. Note that this is using PyTorch Lightning, the default PyTorch Lightning. PyTorch Lightning knows a few things about running on studios through environment variables. So it will just scale up naturally without me having to change anything in the code. So I'm going to go there, install the multi-machine training plugin. And in this plugin, I will just trigger a new run and say, okay, this is my main file. I'm going to run this script on, let's say, two 8NG GPUs, or I can say 4 times 8NGs. Okay, so this is all I needed to do to trigger a multi-node run. We have recipes to pre-train large language models as well. We're running a Llama pre-training ourselves. What happens here is that I get 2 machines right now with 4 GPUs each. PyTorch Lightning knows the topology of what happened. So it will start 4 processes, 1 per each machine, and connect the 2 machines together. This was already pre-configured with everything you need to have fast interconnection between the nodes if the instance is supported. So you can get to 100 or 200 gigabytes per second automatically. We just set it up for you, right? So again, what I was saying at the beginning, you don't leave perf on the table because we do those things for you. You just need to know, because sometimes you just don't know what you don't know. And you will realize after like days that maybe I'm not as fast as I could be, right? So it's a very significant loss that you're incurring in there. And you can go into the machine, and once it pops up, then you can even SSH into it. Now we'll wait for AWS to provision it, but you can SSH into each individual node and have full control of that. All right, so let's go back to our fine-tuning studio. And this is starting for me. And
5 minutes.
Yeah, 5 minutes, it's almost done. Like it only takes for me to spin up a full fine tuning of 13 billion parameter model on the cloud. So that's the thing, right? It just takes minutes. Should it take longer? Not really, unless you really want to get into the details. But this is the speed at which a team should actually operate at, right? So the iteration speed is not hampered by having to think about all these other things that have nothing to do with your core expertise, right? And so I would say that the value of a platform like this, it lets you iterate at the same speed as which AI is progressing today. So you can actually execute on your AI strategy because you're fast. Like if you overfit on today, in 6 months you'll be in trouble. So if you start a big infra project to serve Llama 13 billion, then yes, you'll have Llama 13 billion, except that everyone else will be somewhere else. You need to really shorten the time, iterate, talk to your users, and maybe you will know that the customers actually need something a bit different. And so your best bet is being able to absorb all the novelties, iterate as fast as possible so you can maximize value. So this is the notebook doesn't need to be a notebook, it could be anything. You can even expose UIs from here. You just start your environment. I'm already on a GPU machine. I'm preparing the Alpaca data set. Of course, this is kind of black boxy, but up to a point. You can get into all of these, prepare a data set, and you will see that we're using our own LeadGPT repository, a very hackable implementation of all the LLMs out there. But you can use Hugging Face, you can do anything. And you can actually change everything here. So it's not that you're behind this opaque API. You can hack your way through, you can change everything, or you can also change nothing, and it will just work. And I can launch, give it a second more, and I started to fine tune on the Alpaca dataset using QLoRa, which is a method that you don't necessarily need to know about, but it will fine tune a smaller subset of parameters in the model. It actually will operate on a low rank approximation of your big matrices that you use for attention and so on, using quantization. And so numbers have lower precision. You are dealing with fewer numbers in the end because you express a large matrix with a product of two very thin and long matrices. And this allows you to have very few trainable parameters, but retain the performance of a full fine-tuning. So you can actually pull it off. A 13 billion model on a single A10G means you're running on a 24 gigabytes machine. So it's very small, right? And it's actually quite cheap. And so with all these optimizations, you can fine-tune a 13 billion model with a very low cost in a very short time without talking to cloud providers. Oh, I need 10 A100 nodes, blah, blah, blah. They're going to cost me a fortune. And you can really iterate fast. And then, of course, you can scale up if you want to. Yeah, we will see iterations appearing in a second, but that was what I wanted to tell you. Please sign up on the Lightning platform. If you sign up with your work email, we won't waitlist you. You'll get free credits. Sign up on Discord. I actually have a QR code that you can scan here. Just do that now. See you on Discord or the community in general, or reach out to us directly.
Any questions?
What's the biggest GPU orchestration that you have done to date?
Right now, we're running 64 A100s, but just because I think it's a sufficient scale to demonstrate certain effects. But we've done past that as spikes, but we're actually doing a full pre-training on 64 just to make sure everything is good, and also to make sure that our recipes maximize the throughput for everyone coming in. And so accessing those recipes, we're going to publish it actually really soon. Let me see. It's AI recipes is in our own internal. So I can demonstrate how easy it is. Okay. So this is pre-trained Tiny Llama 1 billion, which we're running on 64 GPUs. But again, yeah, we've done peaks more. But from a recipe standpoint, we have this. You select a team space, you run, and you already have all the setup to use all these GPUs. The only thing you need to do, of course, is make sure that your AWS account has the ability to provision those. Ours has. We manage reservations as well. Oh, one more thing. If you have a on-prem compute cluster, we have a preview for a feature that will allow you to connect to a Slurm. You know the Slurm orchestration? So you can orchestrate your own compute using this workflow. And when you max it out, you can also elastically scale on the cloud. And we support more modalities. It's in preview right now, but it will be released soon to everyone.
Okay, thank you so much.
Thank you.